All right, so last time we talked about type 1 problems in projectile motion. So type 1 problems were the sort that we have a horizontal launch with. So it's something where a vehicle or something launches straight horizontally off of a ramp. And that means that we have an initial y velocity of 0. Now we're going to talk about ramps. So we're getting into type 2 problems. So type 2 problem would be like this rally car jump that you can watch if you want to for fun. Rally car starts off jumping on a ramp, travels some curved path, and then lands on a ramp. Okay, and the ramps are at the same height in a type 2 problem. So we have same height ramp. So that's the sort of problem that we're going to be dealing with today, and that should set you up to be able to solve type 3 problems as well. These are type 3 problems are the ones where your ramp might be at a different height. But if you can do type 2 problems, you can do type 3 problems. So we're just going to jump right into an example today. So we've got young Captain Kirk. He's traveling at 85 kilometers per hour when he hits a jump that makes an angle of 25 degrees above the horizontal. So we want to find out how long he's airborne, how far forward he flies through the air, and what his maximum height is. So I'm going to go to a blank slide here so we have a little more room to work. Okay, so first thing you should do with any of these problems, again, is to draw a picture. So we've got some initial velocity, v naught. We have an angle above the horizontal. Let me redraw that so I've got a little more room here. Initial velocity, v naught. We have an angle above the horizontal that's 25 degrees. Okay. Your initial that I gave to you is in kilometers per hour. So I gave you 85 kilometers per hour. Anytime you see that, automatically the very first thing you should be doing is converting that to meters per second. And remember, we have our super sneaky little trick where we can divide by 3.5, or 3.6, sorry. And you get that if you do dimensional analysis, that would be your conversion. Dividing by 3.6 gets us meters per second. So 85 kilometers per hour is 23.6 meters per second. So that's automatically the first thing you should do. Draw a picture, convert any units that aren't in standard SI. Okay. Next thing, let's write down what we're looking for. So I'm going to shrink this up a little bit here so that we have more space for what we're working on. So what we're looking for is our time that this person spends in the air, and we're looking for how far forward in the x direction they travel, and we're looking for how high Captain Kirk gets in his flight. So let me draw kind of a path of travel here. We've got some x direction, dx. We've got some y max height, dy. And there are a lot of things that we actually know here, some little hidden values that they didn't give us. And I'm going to write down our value here. It was 23.6 meters per second. Okay, so we know up here at the top, we've got I'm going to separate my y's over here. We've got a v Vy equal to 0 at dy max. So at the maximum height, we have a velocity of 0 up here at the top. Okay, other things that we know. We know our acceleration in the y it's equal to negative 9.8 meters per second squared. So that's another thing that we know. Okay, we're looking for time. So we're going to write time equals blank. And in the x, I'm going to just draw a little line here. In our x stuff, we are looking for dx. In our y stuff, we're looking for dy. So we're looking for that maximum height. You could write dy or dy max. Okay, so if we're trying to find our time, well, let's look at our simpler equation here. On the x side, we have vx equals dx over t. We have two unknowns here. We don't have dx and we don't have t. And, I guess we don't have vx either. So another thing that you should do initially with these problems is split your initial velocity, v naught, into its x and y components. So we have a vx here, and we have a vy naught here. So again, we're going to have to look at SOHCAHTOA for this. So our vx is going to be equal to v naught times the cosine of theta, and vy is going to be equal to vy naught is going to be equal to v naught times the sine of theta. Again, look at your SOHCAHTOA. So would be opposite over hypotenuse. Ka is adjacent over hypotenuse. So if we plug these things in, for Vx, we get 23.4 meters per second. For Vy naught, we get 9.97 meters per second. So these are values that we can now put over here. So Vy naught is equal to 9.97 meters per second. And our Vx is equal to 23.4 meters per second. Okay, so now we're going to move on. We have a Vx, but we still don't have dx and t. So that means in order to find time, we're going to have to come over here to the y side. Oh no, coming to the y side. Okay, so looking on the y side, we know some things that I mentioned before, and we know that up here at the top of the trajectory, Vy is going to equal 0. So we can actually kind of break this problem up into two parts. We can think about just this part of the path of Captain Kirk. So we can think about half of the flight. So what we can do is we can use this equation, Vy final is equal to Vy naught plus AT. And we can solve for t. T is equal to Vy final minus Vy naught over A. Careful thing to watch for. We aren't just looking for t right here. We're looking at half of the flight. We're not looking at the whole flight. So if we're just looking at half of the flight, we're looking at half of the time. So this is t 1/2. And this is a common rookie mistake, common area where people get tripped up, is that they think that this is time and then it messes up their other values. Okay, so what we're going to do is we're going to solve this and then multiply time 1/2 by 2. So if we're looking at Vy final is going to be your velocity up at the top here. So that's going to be 0. So we can get rid of that. And then Vy naught is our initial velocity. It's this guy right here. So we have negative 9.97 divided by negative 9.8, and that gets you a time 1/2 of 1.02 seconds. Now we have to multiply this by 2 in order to get our time. So 1.02 times 2 is 2.04 seconds. So this is our answer for time. So that's your answer for part A. So we did all that stuff just to find the answer for part A. But don't worry, this will get quicker. So we've got 2.04 seconds. Now the next thing we can do is pretty quick. The next thing I asked you for was how far forward Captain Kirk travels. So that would be this dx. Well, we have an equation here that is set up pretty simply, and we can go ahead and solve for dx. So dx is equal to vx times time. So if you do that, you should have, let's see, 23.4 times 2.04, and that will give you 47.7 meters for part B. So that's how far in the x direction Captain Kirk travels on his motorcycle. Now finally, we're going to look at this last part. We're looking at how high, the maximum height, so this dy, we're looking for the maximum height that Captain Kirk traveled. So I'm going to have to erase a couple things here just to give us a little bit of space. I'm going to go ahead and erase this stuff. So make sure that you rewind the video and pause it if you need to write down a couple more things. Erasing takes a long time. There we go. We don't need time for this one. Okay. So what we're looking for now is dy. You could use the equation dy equals v naught t plus 1/2 at squared. But we don't really want to do that because that introduces some sort of rounding error. So we want to try to avoid that. If you do use dy equals v naught t plus 1/2 at squared, make sure you're using time 1/2. So make sure you're using this value, not time. Okay, so make sure you're using the 1.02. Because again, we're looking at how high Captain Kirk went, the maximum height, and that happened at time 1/2. So make sure that you only use time 1/2 if you use the d equals v naught t plus 1/2 at squared equation, etc., etc. Okay, so the one that I'm going to use with you is vy final squared is equal to vy naught squared plus 2a dy. Okay, I can solve this for dy. dy is equal to vy final squared minus vy naught squared divided by 2a. Well, we've got some things we can simplify. Vy final is 0. Because remember, up here, we've got 0 meters per second at the top in the y direction. So that leaves us with a negative vy naught squared over 2a. So if you go ahead and calculate this, or plug in your numbers, you should have negative 9.97 squared. Make sure that's all in parentheses, divided by 2 times negative 9.8. And I'm sorry, it's really squished up here. So your dy should be equal to 5.07 meters. So that's your answer for part C. So that wraps up this problem. I know it's a lot of work. I know it's a lot of scribbles. I know my scribbles are awful. But as you do more of these, you will get more and more used to them, and it will get a little easier. And you'll start to remember those little tricks like the time 1/2 trick and y velocity at dy max is 0. So there are all these little things to remember, but just take it slowly, take it step by step. Start by converting your values first, so kilometers per hour into meters per second. Then go ahead and split your initial vector into your resultants, Vx and Vy. And then you can go ahead and set up an X side and a Y side and just write down what you know and what you don't know and use those tools to find what you don't know. Okay? So that's all I've got for you on this one. Hope that helps, and let me know if you have any questions. Bye!